Okay, welcome back to Getting Started with Proofs. This will be part 2. Last part, remember, we looked at the how to learn the definitions, postulates, and theorems. We took a quick look at studying and analyzing some examples. And then in this video, I'm going to talk quickly about planning your proof and then show you how to practice your proofs so that you can learn how to do them yourself. So in the last lesson, just as a quick review, I gave you a list of some things to help you build your own textbook. So here was a list of definitions, postulates, and theorems. And again, most of these I think we'll probably use at one point or another to do some proofs. So I would write these down. I would prefer you to handwrite this though. So you should get something maybe that looks like this. So this is my cheat sheet, and this is my little handbook for what I'm going to actually be writing down for reasons when we're doing proofs. So under definitions, I've got definition of congruent segments or definition of midpoint. Maybe I used a linear pair postulate. Down here I've got the definition of perpendicular, vertical angles theorem, the right angle congruence theorem. So I've got some shortcuts so that hopefully it'll be a little less work when we're actually doing proofs. Of course, you should have also taken those definitions, postulates, and theorems and built your own section called definitions, where you gave all the information we talked about in the last video. And there should also be one for theorems and of course one for postulates. Once you've got all that down, you should be getting a pretty good idea of what we're going to be doing here for working out these problems. So let's take a look at our first proof. First thing I want to review is how are you going to plan your approach to this proof? So my plan involves 3 parts. I look at my diagram and see what I can figure out. I look at the information that is given, either this explicitly given information over here under given or in my diagram itself to see what I might be able to figure out. And then I'm going to go ahead and analyze what they're asking me to prove and see how I might get to that point. A lot of times a good diagram that you've labeled with your given will help give you a pretty good idea of how to go about your proof right from the start. Okay, so let's go ahead and do that. I'm looking at the diagram here. It looks like I've got just a straight segment with a few points on it. The given information, so I'm going to look at the given, says that length AB is equal to length CD. So length AB is equal to length CD. These two are the same. Alright, so that's interesting. And I guess eventually at some point I would be able to show these were congruent if that ever becomes important. And then it says prove that length AC is the same as length BD. So length AC and length BD, that's what we're trying to show, that they're the same. So just looking at that, it looks like these lengths are the same because this is in both of them and then they both have equal segments on each end. So it looks like they have a middle portion which they share, and then they add an equal portion to each end. So this one has AB added on, this one has CD. So that might help me out. A lot of times, about 80% of the time, your first statement here will just be to state the given. So in this case, it's also going to be true. So length AB equals length CD, and the reason for that's just given. Sometimes you'll also have things given in the diagram, and you might list those down too if you think it might be better to list them explicitly. Okay, now we've got to figure out some way to go from given to prove. So I like to look at the given and think of some things that might come directly from this. Well, from the diagram, being a segment with several points, I might be thinking the segment addition postulate. And that just says that the length of a big segment equals the parts. So the length of AC equals AB plus BC. All right, that's pretty common sense. AB equals CD might also be thinking about the definition of congruent segments. So that could be something else we could directly go to, an if-then statement that would go directly from our given. And again, you could spend some time with this trying to figure out where it might go. And then I might go down to the prove and try and figure out, okay, what things come from the prove. There might be a transitive property of equality that gets me to this point. Maybe earlier I find the definition of congruent segments. Maybe I use that as a reason to show that they're both equal, or maybe there's some kind of transitive or substitution property since this is an equality. So there are some ideas to help me get started with the proof. For this one, it kind of pops out what we were talking about in the diagram. This is one segment that's the same that has little pieces added on. So it looks like would be no problem saying that length AC equals length AB plus length BC, and length BD equals the length of BC plus the length of CD. And there I can already see that same length in both of these. So I see the same one here. I also see AB and CD. Those are the two things I was given to start with. Okay, so the reason for this one is this is the segment addition postulate. So there's a shorthand for that. And these are equality. It looks like they've added BC to AB and they've added BC to CD. They've added BC here, they've added BC here, and that'll give us our length for the two segments that we're looking for, AC and BD. B plus BC equals BC plus CD. So here's AB, here's CD, and I've added the same thing to both sides. That's the addition property of equality. Make sure you put the equal sign there so I know that you know that that's just a property of equality. And now if I look, this AB plus BC shows up right there, and this BC plus CD shows up right there. Okay, so I can go ahead and directly, I'll substitute in AB plus BC, I said equals AC, so now I can say that AC equals, this equals BD. And that's what I wanted to prove. So now I got to decide substitution property of equality or the transitive property. So is this an A equals B and B equals C, or is this I'm just substituting in values? And for this one I'm going to say this is more substituting in values. That's a substitution property of equality. So this first proof is done, and again you should be able to look at every step and see an if-then. For the if part of the proof, you should find the hypothesis either somewhere up here in a statement or somewhere over here on the diagram. So this was given, and if this is a segment, you know, if B is between A and C, then AC equals AB plus BC. That's my segment addition postulate. I used it again here. In order to say this, the addition property of equality says that if I have an equal sign, I can add the same thing to both sides. So here's an equality, and I've added BC to both sides of the equality, so nothing should have changed. So if I have an equality, then I can add the same thing to both sides. Addition property of equality. And then down here says if I've shown a value equals something else above, then I can substitute it in. So here I found that AB plus BC equals AC. When I find it again, I can substitute in. So again, go back through every step and see if you can find the if-then statement. And so this will be my last really long, lengthy, tiring example. Hopefully here in our next video, I'll just start going through these a little faster and let you know what I'm thinking, and hopefully get to 2 or 3 of these in every quick little clip here.